Assalamu alaikum all. I hope you all are doing well. So today we are going to cover AI. In AI, we are going to cover how to integrate AI with our Flutter application. And for that, we will be using TF Lite, TensorFlow Lite. So let's get started. Okay, so first let's create a new application, new Flutter project. Flutter create for AI project, we are going to make an object detection application, which means our application will detect live objects through the camera. So, object detection app. Let's open up our Visual Studio. So, first thing first, we will clear out this code, this home page. These both classes, we were going to clear these classes, and we are going to clear this theme as well. We will create our own home page. New file, my home dot dart stateful widget stf, and let's import our material dot dart, control s, and let's call this, let's import a material, my home class, change the name, my home auto import. Okay, so now let's add two packages, dependencies. So the first one we want to add is TF Lite. Let's copy this TF Lite. Under the dependencies. After this, we will paste it. Control S will, or Control S to save this. We'll download our dependency, install our dependency. So basically, what TF Lite is, TensorFlow Lite is a tool that allow us to develop and deploy machine learning models onto our mobile devices. So basically, it allows us to develop and deploy machine learning models onto our mobile devices. So the advantages of TF Lite are it's lightweight, and we know that our mobile phones have limited resources, like we have limited storage capacity and we have limited computation power. So that's why we need something a lighter version of TensorFlow or lighter version of models so that our phone can integrate it easily. Mm. So for that, we have used TF Lite, and the TF Lite have great support in various platforms and uh, various like if you use React Native or if you use a native Android or native iOS, it has great support in every platforms. So next thing we are going to add is camera, because we have a camera. We are going to access camera and we are going to capture live images. So search for a camera package, Control S. Now for the TF Lite, there is one more thing that we need to do. Um, let's search for it. So in this README file, if we go down, it says for the Android, we need to put inside of Android app and build a Gradle file and add the following settings in Android block. So we will copy this, and inside the Android app build.gradle, inside of the Android block, which is this one, we are going to add here Control V. These are some configuration that we need to do, and we might need to change the minimum SDK version as well. We will change later on, but let's just close this and let's edit our home page, create our UI for camera. So for that, we will, what we can do is first we will change this container to a scaffold widget, or we can also change this to safe area, maybe child. Now these are some different kind of widgets and with different kind of properties in it. So we are going to use safe area this time. We can use scaffold as well. So let's add first mm, the safe area will have a child. So inside of the safe area child, we will, let's have a safe area body. Okay, let's have this inside of the scaffold widget. And scaffold widget will have a body parameter. Inside of the body, we are going to create a container. In this container, we will change color, maybe color dot black, and we are going to create a child of a stack, and this will have multiple children. Let's create this function for this stack children widgets. We have a safe area um, scaffold, and then container, and container has some color. We can also have background color. Here background colors dot black, and a child have a stack, and we are going to create this function. So to now create this function inside of the build method, stack, we copy this name. This is a list, so we need to first initialize our list, since children is always a list, so it's stack list, and we have to initialize it null. Then we are going to stack children widget dot add, and this will return a widget. So to return a widget, we will say positioned, and inside of it we will place a container. I put comma to separate things, and inside of this container, we can have our we can initialize the height and width for our screen, so that our camera covers the whole screen. So what we can do is we will create a new variable of size. Size will have a media query of context dot of context and dot size. Now this will have a size of whole screen. So to place this, we are going to say height and width. We are going to use two parameters here, size dot height. Now this will have a height of our phone in which you are running the application. So height of our phone, and we can say width size dot width, and this container we can, let's copy this and paste it up in the position. And inside of this container, we can say height size dot height, and this will have another child. First, let's initialize our camera at the top, and then we will initialize in our UI as well. So to initialize here, we have several camera controller, camera controller. We are going to initialize this first, and the second thing we need to do is camera image. That will have our camera, each and every camera image. Now to initialize it, we will say initiate the camera. This is the function that we are going to create to initialize our camera. And this function will be of type void. Inside of this, we are now this is showing us error because we need to initialize it here due to null safety. We will say question mark. It may be null, or it may not be. So camera controller. This camera controller will have two parameters here, camera and the resolution. Now to initialize this camera and resolution, first we are going to import our camera here, camera dot dart, and Now to initialize this camera, we can say in the main.dart file, widgets.binding, widgets binding, widgets binding, widgets flutter binding dot ensure initialized. And here we are going to pass our camera. Now to pass our camera, we will initialize here our camera first, which is the list of camera description. Cameras. So this list will contain all the cameras that you have in your device, maybe the back camera and the front camera. So I'll import here the package camera, and we will place a question mark so that there's no error, and we will use here async. First we want to initialize our camera before even starting our application. So cameras.await. We will check how much available cameras we have, and we are going to future void. Maybe it takes some time. So future void cameras await available cameras. First, what it will do is we are creating a list of camera description. So whatever the cameras we have in our phone, front camera and back camera, it will be in this list. And then we are going to figure out how much cameras we have. So we have initialized this, and then our application will run. So in this, we are going to pass our cameras that we have just initialized. Cameras and 0, first camera is the back camera. So comma, and we'll say resolution preset dot medium. This is the resolution. You can keep it low or high, anything you want. Then we will say camera controller dot initialize dot then inside of this we are going to use set state, because we want, if the camera controller is initialized, we want to rebuild our widget so that we can see the camera result on the UI. So camera controller, to rebuild the widget, we know we have to use the set state. So camera controller dot start image stream. This image stream will take one parameter of image. Let's change this name to something different. Image from stream. This name can be anything that you want to keep. So if let's create one more variable, that is boolean, to see if the camera is working or not. If it's working, is false. Camera will not be working firstly. Then if here we will check if the camera controller is initialized properly. Then if is working, if camera is not working, now this exclamatory says not, because this exclamatory is before the variable variable name, so it says not working. If camera is not working, and this will be true firstly because it's false. So this working equal true, and we will say here camera image equals image from stream. This is just to this is just we are saving our camera image here so that we can use later on. So And to initialize this method, initiate camera, we are going to use a state, initiate state. This initiate state will run whenever our application runs, whenever we see our application on the screen, this initiate state will trigger automatically. So inside of this initiate state, we are going to call our initiate camera. So we have our initiate camera controller here. Then we have a camera image and initiate camera inside of it. And this tech widget is showing us some error. It says the list is, we are missing here our things. So let's just finish this as well. So what we are doing here is we have created we have created a list of stack widget children, and we have we have created this list above here, an empty list, and we are going to add our camera parameters here. So inside of this child, we are going to say if not camera controller dot value dot is initialized. If it is not initialized, then then uh, show an empty container. And if it is initialized, we are going to say aspect ratio. Aspect ratio will have a camera controller dot value dot aspect ratio. So this is just like an if and else statement. So if it is not initialized, then show something, some container or maybe some error message here. And if it is initialized properly, then show us in the UI camera controller aspect ratio. And after this, we are going to create one more thing, that is camera preview. And inside of this, after this, we are going to say camera child. We are already inside of a child, and this is the container we have and the aspect ratio. Let's run this application first. Let's copy this name if we are missing something. It says the argument list time can be assigned to the parameter. Okay, so list add positions, and position has the height and the width, and then we have a child container height, and then we have a child again, aspect ratio. There's something missing, so that is child have a container aspect ratio. Okay, so we are going to say after this container we can have inside of this aspect ratio we can have one more child, that is camera preview, and camera preview can have a camera controller. Okay, so we are missing a comma here. We have a stack children. The argument type list enemy can be assigned to the parameter. Okay, let's run this first and see what we are missing. Debug anyway. Okay, let's initialize our camera inside of. Okay, we have not initialized it as a widget, so we are going to initialize it here at the top, and we are going to say list of widget since it's a widget. Okay, so camera children is itself a widget, so that's why we need to initialize it as a widget. Now let's run this application in our phone and let's see if we have a camera preview or not. So let's repeat what we have done. So we have first initialized two libraries, two dependencies, TF Lite and camera, and we have also configured inside of the Android for TF Lite. And the next thing we have done here is initialize our camera list description of camera so that we know how much cameras we have, and we have initialized this before even starting or running our application. And then we have our home page, and this home page have and different widgets into widgets and a background color, and this widget have this one list that is the children list, and we have created this children list and list of widget, and then we have this list widget will add the positioned widget, and we have the height and we have calculated the height and the width of our screen. And then we have here we are saying that camera controller is, if not as it is initialized, then show an empty container, else show the camera preview. It says the minimum SDK version should be 21, and our current minimum SDK version is our current minimum SDK version is 16, or maybe it is not less than 21. So let's change this inside of the Android app build.gradle, and here in the minimum SDK version we are going to copy this, or let's say minimum SDK version. We'll copy and paste this minimum SDK version. So SDK, this minimum 16 SDK version basically targets to Jellybeans, and this 21. Let's see. Let's first run this application and then see some minimum SDK versions. So SDK versions. So here we have different SDK versions. So minimum SDK versions means that if we have, for example, if I have Android 8 and my minimum SDK version is 26, so my application will run on my phone. But if, for example, I have Android 9 and I have set, for example, if I have Android 8 and I have set the minimum SDK version of 28, then my application will not run on below this Android 9. So we have changed our SDK version to 21, which is for Lollipop. Now these are some warnings. This is not an error, 7 warnings it says. So the warning is just for the deprecated APIs. We are using the latest version of TF Lite, but it has some deprecated things, so that's why there are warnings. But we can ignore the warnings as long there are no errors. So here we have initialized our camera controller, camera image, and then we have an initiate camera method. We have initiate state here. Initiate state will initialize by itself. Initiate state will build by itself before when we build our application, it calls by itself. So we have called our initiate camera inside of it. Then we have initialized our camera. Our application is now running. So let's see. We have this permission. First, we need to allow this. Allow, allow. Then this shows our the camera preview is working. So now we need to integrate our model. One thing that we can do is here debug, show debug banner false. Now to integrate our model, we will first create a we have here model files, tflite files that is already converted into tflite, and other one is the text file that has some text of the things that are going to detect our model is going to detect. So we are going to copy these both files, and inside of our project directory we are going to create one more directory that is assets. Inside of this asset we are going to paste our model files. I'll close this Android folder. We have here our assets, and to use these assets we are going to initialize in our pubspec YAML file. Assets, this slash means here that initialize everything that is inside of this asset. Now it is successfully initialized. Now the next thing we are going to do is here we are going to load our model. Now to load the module, we are going to create one more function, that is load module. Inside of this load module, first we will say pflight dot close. Now this is necessary here because if any other pflight model is working or it is not closed before then, so we need to first close the pflight model if any other previously model is working there. So we will close them first, and then we will say try and catch. We will print something there. You can also create some alert box for this try catch statement. E dot to string. We can say here exception. Okay, so inside of our try block, um, we are going to say here pflight dot load module. Now this is a built-in function that we can use, and this takes a parameter of model, and this model will be our model name, which is inside of the assets. As that is SSP, we will copy the name, and this will take one more thing, that is labels, and this label will be assets. We are going to change this tflight into txt because it's a text file. We are going to save this response, string response equals, and then we can say print response. Now this is showing us some error. A value of type future string can't be assigned to a variable of string. Okay, so this might take some time to load model. We are going to use await and async, and we are going to use here future. We are going to print here our response to see what is working. So what we have done is we have created a load model function. We have closed the first TF light because if any other TF light is already working, we need to close that. And then we have initialize our model, the name of the model, and it's a built-in function load model, tflight.load model, and it may take some time. So we have used await and async keywords, and it's all wrapped inside of a try catch block. Now to call this load module, we are again going to use initiate state. Now this will just load the model, it will not run the model, which means it will render our model. Now let's run this first. We will stop it and we will again run this. Now, if you are wondering from where I get these models, so inside of this TF Lite package, they have their GitHub repository, readme file. Here it has a GitHub repository. Now inside of this GitHub, inside of this examples and assets, um, here are all the files. I have copied this SSD model and SSD mobile net and SSD mobile net.txt file. I've copied these two files here. So our application is running properly, which means there are no errors. So next thing we are going to do is run our model, and now we are going to create some bounding box, um, so that we can know where which object it is representing. And before doing that, we will take 10 minutes of break and then we will continue again. We will start at 12. So we have loaded our model, and now we are going to run our model. We are going to create one more function, which is which will be of type null. So void say run model. And here we are going to let's first create two variables, double image height and double image width. So since this is still showing us null error, so we are going to use question mark. And we are also going to create one more list, recognition list. It will have all the elements that are recognized. So how to use these variables inside of our run model. We will first use our image height is to camera image that we have already initialized. Camera image, this one. So camera image dot the height of the camera plus point view. Since it's a double, and this is to convert it into a double. So okay, it shows some. Now this exclamatory is after the camera image, which means it says that the value, it says the value that is nullable, that is initialized nullable, has some value. We are ensuring that it has some value. So image width, camera image dot width plus 0.0. Now we have initialized our image width and image height, and we are going to use now a recognition list. So recognition list equals reapply dot detect object on frame, because we are using a live camera object detection, so we are going to use on frame. Now we need to convert our camera images into byte list as well. Before doing this, we are going to use a await and async. And here we are going to here we are going to convert our camera images into byte list. So camera image dot planes dot math. Now to convert this into a byte list, we are going to say here dot to list after this to list, and here we are going to say maybe planes. Inside of this, we are going to return the plane dot bytes. It will convert our camera image into byte, and then we are going to convert. Then we are converting here into a list since it's a byte list. After this, we are going to use a semicolon, and here we will use our image height and image width inside of the detection object on frame. Image height and the image dot height, and the next thing is image width, and the image dot width. Okay, so we also need to have exclamatory sign here, and then we are going to use a threshold of maybe zero point 0.4 or 0.5. 0.5 will work. And so this threshold here, it means that if our image is detected 50% from the model, so it also shows that it is 50% detected. I'll change this value later on to show you some working. And after this run model, after this recognition list, we are going to say is working equals false that we have initialized earlier, and we're going to say set state and the image. And since our camera image is going to render again and again, so we want to rebuild our UI, and we want to convert each and every camera image into bytes. So that's why we are going to use here set state, and we are going to make it false, and then again when it tries to run, here initialize, it's working will equal to true, and everything will start running by itself. So now our run model is ready, but we need to call this model. We have not called this model. Um, we will call this model run model function after this. So here inside of the set state, we are saying that camera controller would start in its stream. Here we are starting our camera, and after starting our camera, we want to detect a model and detect anything that we have in our surrounding. So now it will start detecting, but it will not show some result because we are going to make something appear in the UI as well. Now to do that, after this run model, we are going to create one more function, that is display bounding box, to display the rectangular box around the objects. So to do that, we are going to create a list of widgets here, since we are going to use this in our build function. A list of widgets, display boxes around detected objects, maybe detected objects. And we are going to here take one parameter of size, frame size. So um, here we will, in the build method, we are going to call this if our camera image not equal to null. If our camera image is not equal to null, then only tag children widget dot add, since it's a list, it can add objects. So we are going to say display boxes around detected objects, and here we are going to pass the size. Now this size, okay, so this we are going to call here as well size. Now, or maybe we can say this to be screen. Now it's better. It says causing null. Okay, we will return something. Um, we will say if recognition list, if it is not recognizing anything in our surrounding, if recognition list is null, then we are going to return an empty list. and if image height equal to null, or the image width is equal to null, then we are also going to return an empty list. Or else we are going to create two variables here, double factor x screen, which is the size that we have passed through our UI screen, through our build method, screen dot width double factor y screen dot height, and then this is going to return a widget, list widget. So we are going to say here recognition list dot map. We are going to convert this into a list. So now to use this, we are going to say here result, and here we are going to return a position element to position everything at the right place. We are first going to add here left, right, and top, bottom. So left will be result rect, which is a rectangular box, and here we will say x multiply by its factor x, and the top will be result rect y multiply by its factor y. These are some mathematics. Result rect w, width of the result vector. We are going to multiply this with the factor x, since it's a width, and then we are going to say height result rect h, height for the height h, and multiply this with the factor y. Now inside of this child will have the container. Okay, so this child will have a container. A container will have a decoration of box decoration. Since we are going to create a box, so box decoration, and this box decoration will have a border or border radius. So border radius is going to be border radius dot all from the all sides, and we are going to say radius dot circular, maybe 10.2. After this border radius, this one ends here, and after this border radius we are going to use a border um, border dot all, and we are going to change the width and the color. We are going to say here colors dot green, or width will be 2.2. After this After this, border all and border radius and box decoration. Inside of this box decoration, we can say child. Here we can say child. After this box decoration inside the container, we can say child, and child will have a text field, and text will be dollar result. If we will have this result field here, result, and result will have two things: detected class, the name of the class that we have detected, and after this curly braces, we can say the confidence level of that class, curly braces, and result we will put a round bracket as well, since we are going to convert this integer value into a string. So result, we are going to use one comma because one inverted commas, because we have inverted commas outside as well. So we are going to use one, and here we will say confidence class, and after this square brackets, we are going to say multiply by 100, since we are going to have a percentage, and then after this round bracket, we are going to say toString. Now toString will be as fixed 0, and after this now curly braces, we will have our percentage sign. Then we can have our styling. Styling will be say text style, the normal text styling. Inside of this text styling, we can change the color. Color is dot green, and we can also have font size change. Our font size of 32 or 16, maybe 16. Now the error is showing because we have to convert this list, convert this map into a list. So after this map, we are going to say dot to list, since it will take the list of a widget. So we need to convert this. We have missed a comma, and for this border, okay, so this border will be border radius dot all, and border inside of this, after this border radius, we are going to say this border. So let's clear this out. After this border radius, we are going to say border, and here we can say border dot all, and we will change the colors dot green, and here we can say the width 2.0. I'll remove this length, that this blue line will be gone after this. We have our display boxes, and we have initialized our boxes here. And we have added this inside of this tagged children widget. We want map is showing some error. Okay, so this recognition list. Okay, so there is one more method, overridden method that we want to use. We have used one overridden method that is initiate state. Here we have initiate state, and we have one more method that is dispose. This works when the application is not running, application is at pause. When we press the home page or we kill the application, so this method is triggered. So we want TF light to close. Um, and since we want to free up our resources, so camera controller dot top top image stream. Null. So start image stream, stop image stream. So we have initialized everything. Now let's run our application and see the results. You can make your own model and convert that model into a TensorFlow Lite. Um, to convert that model into a TensorFlow Lite, there's a Python script to convert it. Now let's repeat from here what we have done till then. We have created a one function of run model, and inside of this run model we have tflight detect object on frame. That is a built-in function of tflight we have used, and this tflight function uses a byte list, and we have converted our camera images into bytes, and then we have converted into a list. We have here image height and image width of camera. So we have our camera image dot height and camera image dot width. It will vary according to your phone. And we have here threshold, which is zero point 0.5, that is 50%. If our model has detected a ball, for example, it detects a ball, 50% it's a ball. So our basically Flutter application will show that it is 50% ball. For example, if that ball is detected 40%, then our application will not show that. And to show that 40%, we need to change this to 0.4. We have make the is working false, and we have rebuilt our build widget. That is this build widget. We have set state builds every time. Every time we call the set state, it rebuilds our widget. So we have called here camera image, since we want to convert every single image into bytes. Then we have another function here, which is a list of widget, and this list of widget function takes one parameter of screen, which is a size. We have named it as a screen. So if the recognition list that we have here, recognition list will have all the items that are recognized. So if the recognition list is empty, null, then we will return an empty list. And if the image height of the image and height width of the image is null, so it will also return a null. Then we have created these two variables here, and since it's a list of widget, we need to return a list. So we have converted this into a list, and recognition list dot map results, and this result this position will take left top width height. This is because we want our bounding box to be positioned as per the object. So we have created this rectangular x and y and high width and height of that rectangular box. Then we have a container, some of the decoration box, how much border we want to, is the width of that border, color of the border, and how much circular we wanted, some of the styling properties here. Then we have a text of result that say detected class. So this will show our detected class with the percentage, how much percent it is detected. And we have changed this to string this time to as fixed, because we don't want the percentage to show something like 67.999. So we don't want to show up something like that. So to convert this into a round figure, we have say we have here as fixed, to string as fixed. Then we have added the percentage symbol. We have again some styling properties here. This dispose method will automatically called when our application is on pause. So to free up the resources, we have closed our TF light and camera controller. We have stopped the image stream. So let's see. Let's rebuild this application. Let's show some kind of error. Let's clear out our application and again build it. To string as fixed 0. Inference took. It is detecting something. So this, let's check again what we have done wrong. So here we have a list of widgets and it takes a parameter of screen. If recognition list equal null, it will return something, return a null empty list, and then we have an image height, double factor. Let's change this again to screen.width and screen.height, and we are returning here a recognition list dot map result and return position. Then we have a left rect. Let's check this rect x, rect y, rect w, and rect h. Factor x, factor y, factor x, factor s, multiplying all factors here. And then we have a child of container, decoration of box decoration, just closing properly. Then we have a border radius dot all, border radius dot circular, and then we have a border dot all, color of the border, width of the border. Then we will add one comma here, and we have a child result detected class, and then we have a confidence in class. Okay, let's run this. Now this is showing some result, a keyboard, let's say laptop, keyboard. It says laptop, keyboard 67%, 69%. So if we change this threshold, it says 67%, 63%. If we change this to zero point 0.7, which means 70%, it will not show us result, or it might show some result in rare cases. So now it is not showing any result. It says laptop 74. If we change this to zero point 0.8, now this is not showing us any result. So again changing this to zero point 0.5. This name should be the exact detected class and confidence in class. And we can also change this to see, for example, if I change this to 1, control S. Now, now this shows point 63.7 or point something. So it's at point 1 digit. And if I remove this the two string only, now this is returning some different kind of statements. So to have the fixed value, we have as fixed 0. We can add padding if we want to around these corners, since this keyboard case is on the left side, so we can add some padding and different things. So you can create your own model and try this by changing the assets here and changing the name of the model into the load model. Here you can change the name as well and try different models. So the other thing I can show you is image classification model. But I'll, we can create one model as well, but let's just show you this application of fruit recognizer. This is not basically a fruit recognizer, it's cat, dog, and bird recognizer application. So this is just the same as the previous we have created, just created. Now the difference here it is that it takes a picture from the gallery and then detects then what it have in that if that is a person or a laptop or anything. So otherwise it will have the same load model and load model and classify model. Classify model here is a run model. It says run model on image because it's not a string now. And then we again have a set state and there here we have a loading that false equals false and output that will rebuild our widget whole widget. We have picked the image. That's the same thing. So to change the models here or to create a one model here in the assets file, what we can do is I'll show you how you can create your own models if you don't know how to create it. There's a one website that is Teachable Machine. You can use this website to create one model and test it out and get started. And here we have three different kind of projects here: pose project, audio, and image. We will be using image project here. Standard image. Here we have a classes, different classes. We can name these classes. For example, a cat class. Then we can have another dog class. We can upload our cat and dog images here. You can download the different images dataset from the internet. I've already downloaded it. Cat images and dog images. It's a very small dataset, but we can use this. So to now to upload images, you will click the upload and choose images from your files. And here we can say cat images. We will control A, select all the images and open. This will load all our images. And here for the dog, same steps. To add another class, we can say add class. And we can name this class as birds or bird load. And here we can click the train model. There are some advanced options that you can use. For example, the epoch, batch size, learning rate. Um, I'll let this be default and I'll click the train model. It will train take some time as per the images since we don't have much data set, so it might be quicker. After training this model, you can export this model. And I have already exported this model. You can click on this export model button and here you have three options. We will choose this TensorFlow Lite and TensorFlow Lite we will be choosing floating point and we will say download my model. It will convert our model into TensorFlow Lite. This will download the TF Lite model and the text file with it. And this can only be used in this cannot be used in live detection since this is the image classification model. This is not a YOLO model. We will wait for this to convert. After converting, it will start downloading, and we can change this with our asset file. But this will pick the images. This will not detect in real time. We can also capture images, take a picture. In both cases, we have one open camera and open gallery, and this image picker we have initialized our image picker here. Image picker and meta and TF Lite. These three we have initialized. Then we have inside of the home page, we have picker.get image. Since open camera will use image source.camera and it will open the camera, and the open gallery will use a gallery as the source. Then we will re-render our build widget and we will classify image, and we are passing our picture object here, and classify image is just as run method, run model, and this classify image will be same as the run model on image. Let's see. Now this will start downloading. We will name this our models. I'll close this. Now in the download, we have this our model. We will extract this. Now we can use this inside of our application. I'll show you the results. Let's copy this and paste it inside of this. So to paste it inside, we are going to replace the file. Let's just run this application and see some results. This main dart file is just calling the home page. This build method has some styling again. If it is loading, then it shows the container, different container. Else, if it's loading, it shows some different container, then circular progress bar, or else it shows some image. It will pop up a container that says pick up an image or pick up from that gallery or capture the image. This is on press button. We have created a separate method for it. which is a camera method here. Here we have the path of that image. Now, if I click on this floating action button, which is here, this method will trigger. So I'll click this. I'll say select image, and I'll use this one. Now it's a two bird. Why it's a two? Because inside of our label class, this one label class, we have 0, 1, 2. So I'll remove this 0, 1, 2. I'll change this text to something cat, dog, and bird. I'll save this. Now let's again choose select image. Zero cat. We need to rebuild this whole widget, a whole application to change this label text. Well, we normally don't create models through this teachable machine learning. But if you want to create your own model and test it out, you can create that. You can also visit this GitHub page to see what else they have. They have also PostNet, which is position that we have seen in Teachable as well. You can also see the examples here. If I search for the TF Live, this example, and this shows an example of how we can use different models. In our case, we have used this SSD model. How you can even build this application and see the results as well. Now it says bird. Since we are using the same images, so it's 100% accuracy. We can try out different images. We can extend our data as well to see some better results. So that's all about AI. But you can also have any different things to use. You can also use like API for it. You can create your own API, and then you can pass the camera images into your API, and that API will return a result back into your application, and you can show that result as a text or anything, or maybe add a bounding box or then text. But the API will require a network request. Um, since it's already a network request, so this model will not require a network connection to be there. So that's all about it. If you have any questions, you can ask. Since this is the last class, I hope you have learned something from this course. And thank you all for joining this course. And if you want to learn Flutter in future, you can follow some other tutorials as well, like some tutorials on YouTube. When I started learning Flutter, I followed the Nat Ninja channel that is on YouTube. I followed him, and then after that, I followed different resources and tried to create some project. The more errors you will get in development, the more you will learn. If you need any of my assistance, you can contact me on my number or you can email me anytime. Thank you all. I'll share you a feedback form on WhatsApp. You all need to fill that form. You can leave if you not have any other questions.